Hello everybody, this is Todd Frazee again, and this is the video tutorial for the S60-51 CAD for the cylinder assembly. So this one's going to bring together uh, individual models you've made, some components from a master car, and one of your sub-assemblies you did as a prior assignment. So if we were to go over and look at the drawing, the S60-51 is made up of item 1 and 2 are some McMaster car items. So you have a couple dowel pins and a couple O-rings. And then the S60-131, which is the secondary cylinder. The Dash 105, which is the rod end, number 4 over here. You should have made that early on in the class. The Dash 107 bushing, which is one of the first projects you did, and the Dash 101, which is the most complicated part, individual model part. And it also brings in a sub-assembly, so the Dash 53, which was made up of 3 components. So before you start, you need to assemble all these models in the same folder, including the hardware. I'm not going to go over how to download hardware from McMaster Car, but you can refer to the Dash 53 or Dash 55 or Dash 57 assembly videos for instructions on how to download the McMaster Car parts. You will also need any hardware that was in any sub-assembly. So you need all the models together and the assembly files for sub-assemblies. So if we're to just go over to our file manager, you're going to need all of these files before you even start. So if you don't have all of these in one place, please pause the video here and proceed when you've gathered all of these components in one place. Okay, we've gathered all our parts and our one sub-assembly file, which is the Dash 53, including the parts that went into the Dash 53. And we've assembled all the components that go into the Dash 51. Now we're ready to go to SolidWorks. Okay, so we're going to go to SolidWorks and we're going to make a new file. And we're going to accept the defaults there. Oh, hang on there. Make a new file, assembly file. Okay. And it's asking what's our base component. Again, I would suggest you use the most complicated part or one that everything mounts to. So I'd say that's probably the Dash 101. And you're going to bring that file in. Now I want to make my origins visible. And I also want to orientate it in the same axis as you would see it in the isometric in the drawing. So right now this pocket we have in the top is facing forward. So let's go ahead and rotate this around the x-axis 90 degrees, 90 degrees, and 90 degrees again till we have it facing upwards. And then if we hover over our origin, we should have that snap in place. And we don't have to do a relationship. And you should have an F here for the first feature. Okay, now I'm going to go and I'm going to make those origins invisible because I don't really need them for this. Okay, here we go. So we have our first component in, and we're going to go ahead and save off our file so we don't forget to do that. And we're going to call it the S60-51 underscore R0 underscore T underscore Frazee. Okay, with your name in there. Okay, so now from this point, we're going to start bringing in components. So we have, let's see, we could bring in, why don't we go ahead and bring in the secondary cylinder. So we're going to go to assembly mode, we're going to insert components, and we're going to browse for the 131 and open that file. Click anywhere in space with the left button. Then with the right button you can drag on it and change its orientation by spinning the individual component. And we're going to do a mate between the diameter of the bottom of the cylinder and the diameter of the pocket that it goes in. And we'll go ahead and lock rotation and accept. Okay, so now we should have a cylindrical concentric relationship there. And now we're going to select on the bottom of the pocket and the bottom of our secondary cylinder to make a coincident relationship between the two. Okay, so now we have the second cylinder sticking up from the top. Pretty easy peasy, huh? Okay, now let's put the bushing in. That's the dash 107. So we're going to exit mate mode and go to insert components, browse, and we'll get the 107. Okay, that's our bronze bushing. And we're going to do something similar. We're going to go mate between the outside cylinder of it and down inside here we're going to select on the pocket that it goes in. We'll lock its rotation and we'll hit accept on that. Now it's floating in space. It should be concentric, but we're going to drag it out into white space here so that we can access the faces we need to do the mate on the bottom. So we're going to do a mate between the bottom of the pocket that it presses into and the corresponding face on the bushing. Okay, and we're going to accept that. So now if we rotate around, we should see the bushing down there in the bottom of the cylinder pocket. All right. Now what should we bring in next? I think we'll bring in our two O-rings. I'm kind of doing this in the order I would probably assemble this whole thing. You would have to put the O-rings in before you put the piston in, because we wouldn't be able to get access after the piston is soldered in place. So the piston's going to be captured by the dash 4 soldering the number 4 item, the dash 105 rod end, and being soldered onto the end of the dash 53 item number 7. So let's do that. Let's get our O-ring. So our O-ring part number ended in 684. So we're going to insert components, we're going to browse, and 864 should be an O-ring. Okay, we're going to open and place that O-ring. And then I'm gonna make sure I save. First, I'm gonna rotate the O-ring so it's roughly in the orientation it would go in our piece here. Okay, so we've brought in the O-ring, which is a circular part, but it doesn't have any flat edges to make concentric with anything on the part. So in lieu of having a concentric relationship, we're gonna make our temporary axes visible. And this will allow us to do a mate between the axis around the rotation of the O-ring and one of the axes that's centered on our part here. So it doesn't really matter as long as those are all aligned, and it's going to make a coincident relationship with it. Okay, so it isn't concentric, but the center axes are considered concentric. Okay, and then because we have a round profile, we're going to select the face of the O-ring, and we're going to pick the back of the first O-ring slot. and it guesses that I want a tangent relationship, but unfortunately it threw it on the wrong side of the wall and it's embedded in the part. So I'm going to reverse that relationship, and I'm not sure why it's not rebuilding, but if I hit OK and close this window, I get a bunch of errors, and once I rebuild, it pops it in the correct location, so it's actually in the slot. Okay, so we want to put a second one of those in. Okay, we're going to save the part. We're going to select the component on the tree. Press Control V, click out in space. Control V, so C and then V, and we get a second O-ring part. We're going to repeat the procedure we did before. Center axis to center axis. We're going to accept that. We're going to pick on the face of the O-ring, and then we're going to pick on the back face of its corresponding slot, and it predicts a tangent. It's on the wrong side of the slot, so we're going to reverse that, and it looks like it popped to where it's supposed to be, and we'll accept it. So we have our two O-rings, and those will compress when the test tube is pressed in. The heating tube is what it's called. Okay, so we're moving along pretty well. We've got just a few more components to do. All right, so the next component we're going to bring in is actually the subassembly. So we're going to go Insert Component, and we're going to browse, and we're going to select the -53, which is a assembly, and we have some different modes here. So I'm not sure what speed pack is, but using large component assemblies is going to suppress some of the features like threads and hardware, so that the entire assembly runs faster. But you often have to rebuild more often. This is a small enough assembly, so we're just going to stick with resolved. But the lightweight would open faster on a slow computer if you have a really large assembly. So we're going to hit open, and that's going to bring in our entire primary piston assembly. And just to get rid of some of the clutter, I'm going to hide the temporary axes. Now the orientation's backwards, so we're going to flip it around. Okay, and we're going to mate between the shaft, exterior of the shaft, and the center of our bushing. And we should get an automatic concentric. We can go ahead and lock the rotation, that's fine, although in reality it probably wouldn't be. And now we've got that whole subassembly is now can move back and forth inside the cylinder that it goes in. Okay, and we're going to leave that motion capability there. Okay. All right, now let's put the let's mate the rod end to it. So we're going to go to Insert Components, we're going to browse, and we're going to grab the -105, okay, which should be our rod end. Okay, and we're going to do a mate between the inside pocket and the corresponding cylinder to mate those together. In this case, we're not going to lock rotation. We're going to hit accept because we want to turn this to be a very specific orientation. Okay, so we're going to drag this back out because we can. And we're going to mate the bottom of the rod to the edge of the bottom of the hole where it would press in or solder in, and we're going to accept that relationship. Okay, it's now stuck on there, but this piece can rotate in relationship to the rest of the assembly, which we don't want because it can be that way right now, but once we go into the next level assembly, it's got to line up with a joint, universal joint. So let's try a couple things. We're going to make our temporary axes visible again. Okay, and we're going to try to mate one of these faces. and we're going to make it parallel to this vertical cylinder. And now, no matter where we go, that piece will be parallel to it. We're going to hit accept. And now we can still move the component back and forth, but it won't be able to rotate. Okay. Now, let's make our temporary axes invisible again. And I'm going to select the main cylinder body. We're going to make it transparent so we can see what's going on inside. So the real travel limits of this component is it could travel to about there and it can't go any farther. So we're going to go ahead and position it there. That gives us the most amount of linkage room when we bring this into the primary assembly. Okay, so now we can, but that's kind of neat. You can use that to do like an X-ray view of the model. Okay, so let's change the transparency of that component back. Every time you save, it's going to ask you to rebuild. Okay, so we have just two components left, and they're dowel pins that press into these two holes. Insert component, we're going to browse, and we're looking for the dowel pin that ends in 494. Okay, we're going to open that component, and we have one instance of it at the moment. We're going to mate its diameter to the top hole. Okay, and we'll lock its rotation. We're going to accept that. And we're going to drag it back out. And we're going to pick the edge, not the bottom. Yeah, we're going to pick the edge of the hole. And then we're going to rotate around. We're going to pick the face of the pin. And we're going to make those coincident. Okay, so our first pin is locked in place. Alright, let's exit the mate command. We're going to save it. Okay, so we're going to copy this component. We're going to highlight the component on the tree after we've saved and hit Control C, click out in space, Control V, we have our second pin, and we're going to mate the outside diameter of the cylinder to the inside cylinder of its corresponding hole. We'll lock its rotation. We'll accept. We're going to drag that component out, and we're going to mate between the edge of the part hole and the face of the pin for a coincident relationship. There we go. We've got our two pins pressed in where they should be. Now the holes are different depths, so you should have a difference in height sticking out of the part. Alright, that's it. That does it for this assembly. This is probably the more complicated assembly, take a little bit more time. But as you'll see in the next assembly, this helps because you're bringing larger and larger pieces into a bigger assembly, and you're not going to be quite as overwhelmed with the number of pieces and mates involved. Okay, make sure you save this in a safe place on your H drive, and we'll be needing this for the next assignment. Alright, well, I'll catch you on the next one.